Hi, hello. This is for CAP4773, uh, Intro to Data Science, the term project, and predictive machine analysis. And we're just gonna go over what I did. And for it was a pretty large data set, so but it was missing a lot of information. One thing I noticed was that sensor 15 was completely gone of data, so I just removed it from the data set, uh, so it wasn't considered, and a lot of gaps as shown from here. You can see that a lot of missing data. There's some depth all the cells that are missing. And you see like the 10,000s to the 77,000s. And what I did was use k nearest neighbor imputation method to to fill up any missing information, but as well as provide somewhat precise information in what needs to be filled so that it doesn't create high variability in the data set. So, it's just checking everything and then moving on to next, we explored exploratory data analysis. And what I did was just graph the relationship of the sensor data over time, as well as have that machine status over time as well, just so we can reference back and forth. So, and as you know, you can notice some noticeable relationships with some of the sensors and machine status, as we can say for not sure if it can be seen, but let me increase the size. Actually, you can notice some data over here, right? So we can notice for like the little sensor 4, it has like a little spike down every time it's recovering, right? We can notice these little drops, right? But you see how sensor 5 behaves along with others right here. You see, not so much noticeable changes, but you can see a little for sensor 11, stuff like that. But sometimes it's not visually clear, because it seems kind of messy at first. We can only pick up some of the stuff. Um, oh yeah, also for data preprocessing, I wasn't sure, but I kept in the outliers because as you can see, like huge reading on 1000 for sensor 50, right? But for some reason, you can see it correlates really close to the machine status. I decided to keep it in, but and with all the high variability, we kind of need to tone it down. Also, this image is a little bit too big, but for the feature engineering, try to pick out what sensors might provide some insights. So what I did was it's just a regraph of all the sensors, but we did rolling statistics on the information on the data. And for the mean, it'll smooth out the data. So it can be originally seen from like number 4, but for the 4 right here, big squiggly lines, right? So we don't want that. So it just straightens it out, makes it more readable. And obviously you can see the um, relationships, right? And then just moving down to the rolling mean, just going through it, right? It just smooths out the line. We go to rolling standard, and that's where we kind of see the variability, right? Little pop-ups where it varies highly, right? Then you can do that for all the sensors, right? And then for the trend, where it kind of peaks high. Kind of remember my notes. Apparently not, but trends where kind of peaks the trend, and then we did lag as well, or kind of did by one time back, and then we can just read all the information here, see how it correlates to the machine status. And with that, uh, we continue with the predictive modeling, and I chose three predictive models: logistic regressions, random forest classifier, and support vector classifiers. And you can see my code here. It gave like accuracy, precision stuff. All of them perform really high, but out of all of them, the support vector classifier performed the highest. But really, um, just to be sure, I also tried to do a k-fold, but that seems at the moment is not working properly. Uh, But as you can see, support vector classifier is working at highest, but really, any predictive model will suffice uh, in this of this nature of a problem. Yeah, that's it. All right, thanks so much for watching.